Hello all. In this video we're going to take a look at some more elaborate examples of functions and writing programs with functions. In particular, we want to focus on how the main script might interact with a program and also with programs that have more than one function and where one function might call another function that you've defined. So understanding exactly how all that happens can be kind of tricky. We're going to look at it here in one form, and then I have another video that I'm thinking about that uses something called the happy robot metaphor as a way of explaining what happens with the series of function calls. So we'll see if I do that as well. All right, so I'm going to start with a big picture idea. When you write your code in a Python file, Python is actually pretty lax. You can put things in a lot of different orders and Python will be happy with it. For readability's sake, we humans need us to be good to each other. So we need to include comments in our code, and we need to structure our code in ways that are standardized and that makes sense to a lot of people. So there's a standard layout that is good Python style that I'm going to encourage you to use and eventually require you to use. But it's not that complicated. So hopefully this will make some sense to you. So what you want to think about when you create a Python file that has functions, it may have import statements, and it may have a script part that's actually calling the functions and having them do things. There's a certain order to put these in the file. You want to start at the top after you have a descriptive comment. I'll talk about documentation in another video, but after you have a descriptive comment, you want to put all of the import statements. It's good to have them there when you're writing code in this kind of a format, just because it makes sure that you know exactly what your program depends on. It's all right up there at the top. The second thing you put in the code file is the function definitions in some organized order. People differ about what the right organization is. I'm not that fussy. I typically will put the main program, the main functions at the top and their helpers down below. But you find some sort of logical ordering and you just put function definition, function definition, function definition all the way down with no script elements mixed in. It's the mixing in of script elements with function definitions that gets really confusing. So you want to have a function definition, and when it's over, you go on to another function definition until they're all defined. The last part of your file, that's where you put all of the script elements. All the calls to the functions, all of the global variables that you want to define, just put them down at the bottom of the file. There are some other styles people use, but this is a really good one, especially as you're starting. Another thing that I want to emphasize to you is the importance of using blank space to improve readability. I don't know if you've ever looked at someone's paper where they have not divided their work into paragraphs, and it's just like a whole bunch of words and there's no breaks anywhere. That's really hard to read. It's really hard to make sense of and to follow like the flow of the author's thoughts. In the same way, when we write programs, we need to separate our thoughts from each other. So use spaces to separate elements of a list, to separate the parts of an arithmetic expression. Python doesn't care. It will understand what you do, whether you put those spaces in or not. But it's much easier on us humans who have to read your code, including yourself, if you do this. Use blank lines between elements of your file, so between function definitions, between sections of a function or sections of a script. Use comment lines. It's actually really common style to put in comment lines that have where there's no actual text on the line. It's just like a bunch of dashes or pluses or equal signs. It makes a visual horizontal line across your code, and you can use that to separate sections of your code and make it more easy to visibly see what's going on in your file. Visual separation is a good thing, so you should do that. Other things about style, PyCharm likes to nag you about style. I don't know if it's turned on by default. It is on my PyCharm because I kind of enjoy trying to match style. There's standard styles for Python that people have gotten together and agreed upon, and PyCharm can check for those for you. I turn certain things off because it doesn't like the style of variable that I like to use, and but otherwise, it's actually kind of helpful to know that if you're meeting the style or not. So like light tan warning messages are about style. You can ignore those. Or if you like, you can look into them and see if you can learn what the official Python style might look like. Documenting your code is really important. So having that string at the top, that triple quoted string that describes the overall contents of the file, and then for every function you write, including a doc string, a triple quoted string right after the header line and before the body. Why is this important? It's good style, but also the help function that we looked at when we first started looking at modules. The help function can be run on your code too, and it will print the content of those triple quoted strings. So you should try it out sometime. It's kind of cool. Okay, I want to talk about main programs a little bit and flow of execution, then we're going to take this example and kind of work through it a little bit. So generally when you write your program, it might have a bunch of function definitions, but there will also be a main program, the main driver of everything. In your readings, it talks about making a main function, and you can do that. That's really a common style, to have a main function that handles everything, so that really the only script element in your whole file is a call to that main function that says go run main. You can do that. I might show you an example with that. It's very usual that if you have a main program, that it's either the first function in the file or the last function in the file. And often people call it main. This is a holdover from other programming languages where you absolutely have to have something named main, M-A-I-N, that is the main program. It's not required in Python. You can call it anything, but it's often called main because we just know this. Instead, what you can do is just have a main script. So down at the bottom of your file, you have a script, and that script runs the whole thing. I'm going to pull back up an example we had before. Let me switch over to PyCharm, and I'm just going to illustrate this. Oh, good. I still had it here. So we had this smallest diff. I could make a main function that calls smallest diff. All right, so it's a very simple main function. And then I would call main at the very bottom of my file. And notice that's the only script element that's there. It's fussing about that. That's the style fussing. So it's the only script element. It calls this function main, and then main's going to call smallest diff. So this is, again, a multifunction program. One function calls another. So this would be one way to go, and I'm going to go through exactly what happens when you have one function that calls another in a little bit. But I want to show you the alternative to this, which is I don't even necessarily define a main function. But what we often do is we use this really arcane, cryptic notation. So we put an if statement in here, and we say if underscore underscore name underscore underscore equals the string main with underscores, then do these steps. Why do we do this? It's kind of, it's a little complicated, so let me explain it carefully. When I run my program, when I hit the run button up here, the first thing Python does is to set this name variable that belongs to Python. It's one of those special variables and it belongs to Python. It sets it to this special string main, which says I am directly running this file. If, on the other hand, I were to treat this as a module and I have another code file that I'm going to import function examples into, then when I say import function examples, Python changes that name variable to the name of the file. So it would set name to be function examples. When I put this if statement in here, it guarantees that the script elements that actually cause this program to do something don't run, or they only run when I'm directly running the program. They don't run when I'm importing the program into something else. Because when I do that import, typically what I want are the function definitions. I want those functions defined for me in my other code file. I don't really necessarily want this script to happen. So it's a useful way to deal with importing code from one file to another. We're going to do more of that in the future. We haven't done that much yet, but we will very soon. So this is just a good habit to start getting into. And when I do examples and provide you with code, I will often have this. Another way to think about it is that this is your main program right here. All right, I want to come back to my notes. We are going to look at this example. So I'm going to copy it. You notice it has two functions, and then it has some script elements right here. I could put that into the form that I was just talking about. So we'll go back over to PyCharm. I'm going to get rid of smallest diff. We've spent enough time with it. Now, things I would do to change this, it would be a good idea to have a triple quoted string up here at the top that says this is what I usually do with this is I'll say file, function examples.py, author, and then I'll just have a sentence that describes it. This contains examples of functions for learning about function definitions and calls. That's it. That's a doc string. The next thing I would probably want is to do the same thing for these functions. Takes in a number. I'm guessing it's a number because I'm adding 2 to it right here, and prints it, then returns the number plus 2. Prints. So it takes in a number and it prints the number plus 2, and then it returns the number plus 2. Function B, what does it do? Calls function A. Reassigns Y to be the result. Prints Y, then I'm kind of repeating what is actually in the steps here. I'm almost writing pseudocode in my comment, which isn't usually what we want, but these functions are just for examples. So they don't actually do that much that's useful or interesting, so I don't have a whole lot else I can say. Okay, like I said before, we could do this if name equals main. And then we just will indent these. Highlight them all, hit tab. They're all indented. All right, so I have a function definition. I have another function definition. And then I have my script. I'm going to scroll this down so I can see all three. What happens when we call this thing? I could walk through this by hand, but I think what I'm actually going to do is practice with the debugger again. So I'm going to stop the program right there at that very first line of the main program, and then we'll walk through it and see what happens. Okay. So we're stopped at line 1. Notice name here is main, and notice that function A and function B are defined. And then I'm going to step. So we're going to print. You don't really see the print, but if you go over to the console, that's where the output will show up. And we'll go back here. We have a for loop. We're going to repeat this 3 times. I is 0. We're going to call func B with I. And notice now we have y is 0. So the value 0 got passed to y in here as y. We are now in function B, and we're performing its steps. The first thing it does is call function A and pass it 0. So now x is 0 in function A. That's going to print a message. And again, you can go over to the console and make sure that those messages are printing. So it printed x plus 2, that was 0, x is 0, so it's going to print 2, and then it returns 2. And now notice y has changed here. Y is now 2. And we're back to func B. We're going to print a message, and then we're going to get down to the bottom line. We're going to call func A again. This time x will be 0. Oh, sorry, y changed, right? Y was 2 now, after we called func A the first time. So now we're going to call it with 12, which is in fact what it shows here. It's going to print that, and then it's going to return 14. And y will be 14. But then func B ended. That call ended. We came back here. We're now going to go around the loop again. I equals 1. We go back into func B. We go back into func A from there. We come back to B. We go back into func A again. We come back to B, then back to the main program, and then we go around the loop a 3rd time. So there's a lot of jumping around here. Then we finally get down to this last print statement, and then the program will be done. Function calls cause this kind of jumping back and forth. And you can have one function call that calls another function that you've defined. What happens is this one pauses, and then the other function takes over until it finishes, and then we come back to where we were before and continue. There is a whole infrastructure inside our programs that support this kind of function call and return. And the happy robot metaphor is a metaphorical version of that. So I think that's where we're going to stop. We've looked at this example. We've talked about main programs. We're going to stop there, and then I'll have a separate video where I go through the happy robot metaphor and show you. It's just another way of thinking about what's happening that can sometimes be helpful to remember how these function calls interact with each other when you have one function that calls another one. So I will see if I can do that in another video, and I will see you all very soon.